Hello guys, welcome back, and let's handle this task very fast. So in this lab, we are going to look at hot standby routing protocol, that is HSRP, which is a Huawei protocol that is help us to implement reliability and also provides availability. So fault tolerant provide continued operation in the event of a device failure. So in case a device goes down, our network should be able to continue operating. So that's where we are going to implement reliability and also availability, so that when one device goes down, the other device will be able to take over the role over of the active device. So HSRP is our way proprietary protocol, and we have got an vendor proprietary protocol, that is VRRP. So VRRP is not vendor specific. Any vendor can use the VRRP protocol. And also after this lab, we are also going to look at the gateway load balancing protocol that will help you now to distribute the workload in multiple devices. So, but in this lab, we are going just to look at how can we configure our standby routing protocol, so that when you look at ISP router one here, will act as our gateway one. So when this ISP1 goes down, this ISP2 should be able to take over the role of ISP1. So that is the task that we are going to do in this lab. So let's look at our lab scenario. So this is the topology, and let's look at the task we have. In our task number 1, configure routers with IP addresses as shown in the topology, and we are also going to enable password as CCNA. Then configure various PCs with IP addresses, the default gateway to be 192.168.1.3. That will be the HSRP virtual IP. Then number 3, configure default routes on router 1 and router number 2 pointing to ISPs. And next, we are going to configure OSPF on ISP1, ISP2, and the internet, the router above. Configure then NAT overload, port address translation on router number 1 and router number 2. Configure HSRP, that is the task. So we go now into our lab. So in our lab, we are going to first of all set up the password and everything needed in each and every device, so that we implement security. We're going to go to our notepad here. So a no IP domain lookup. Then we're going to you enable a secret, and our secret here will be CCNA. After that, we are going now to enter the line console, console 0. Password here will be Cisco. Tell it to log in, then login synchronous. Then enter the line VTY 0 to 15. Password will be Cisco, and tell it to login. Login synchronous. After that, we are going to set the message of the day. So banner MOTD, message of the day, then use the sign. Let's use the $sign. After that, we are going to enter the message that, then give it that message. So tell it a Qualcomm networks authorized. You must ensure that it ends with that $sign. After that, we are going to copy all this configuration and paste them on each and every device. This one is just help you to implement the part of security so that only authorized users can log into those devices. Don't just let anybody just log into your devices and tamper with your devices. So say no, enable config terminal. This is, then we give it a host name of, this will be router number 1. So on router number 1, we're going to paste everything, enter, then exit and see if now, okay, if you exit, you can see now the message of the day has popped up, a Qualcomm network authorized. Then we are going to type the login, so Cisco for the console, then enable. In the privilege executable mode, we are going to give it a password of CCNA. So that is done. Then we enter the interfaces and also give them IP addresses. So we're going to enter interface, this interface gig 0, then the upward is interface gig 1, and give them IP addresses and also description. So config terminal interface gig 0/0. IP address here will be 192.168.1.1, mask of 255.255.255.0. Description here is link to LAN. Tell it no shut to bring the interface up. Then enter interface gig 1. IP address here will be 100.100.100.1 with the mask of 255.255.255.252. That is because it is a /30. And description here will be a link to ISP1. Tell it no shut. Now we are on this ISP router. Tell it no, enable configuration terminal, and host name here. Host name, this one is ISP1. After that, you enter interfaces. So in this, you have got gig 1 and gig 0 with the IP addresses shown there. So interface gig 0/0, IP address will be 110.110.110.2, mask of 255.255.255.252. Description here, this is a link to internet, a link that connects to the internet. So tell it no shut. Enter gig 1. IP address here will be 100.100.100.2, mask of 255.255.255.252. Description here will be linked to router number 1. I bring the interface up, tell it no shut. That is done. We are now on our internet router here. On our internet router, we're going to configure the loopback and also the IP address for the physical interfaces. No. So enable config terminal. Host name here will be internet. After that, enter the interface gig 0/0. IP address here will be 110.110.110.1, mask of 255.255.255.252. Enter. Then description here will be a link to ISP1. Then tell it no shut. Now we are on interface gig 0/1. IP address here will be 210.210.210.1. The mask of 255.255.255.252. Description here will be a link to ISP2. Tell it no shut. After that, we create a loopback interface loopback 0. IP address here will be 8.8.8.8. The mask of 255.255.255.255, because it is a /32. Enter that. So after that, we are now on our router number, ISP router number 2 here. No shut. Enable config terminal. Host name here will be ISP2. We paste the logins. After that, you enter interfaces. So interface gig 0/0. Sorry. IP address will be 200.200.200.2. The mask of 255.255.255.252. Enter. Description here will be linked to ISP2. No shut. Then on gig 1, IP address will be 210.210.210.2 with a mask of 255.255.255.252. Description here will be a link to internet. Then you tell it no shut to bring all the interfaces up. So after that is done, we need to come to this our router number 2 here and also do the same. Say no, enable config terminal. So host name here will be router number 2. We paste the login. So after that, you enter interfaces. Interface gig 0/0. IP address here will be 200.200.200.1 with a mask of 255.255.255.252. Enter. So description here will be a link to ISP2. After that, we're going to enter. We tell it no shut to bring it up. Then we enter interface gig 0/1. IP address here will be 192.168.1.2 with a mask of 255.255.255.2.0. After that, a description here will be a link to LAN. Tell it no shut. So having done that, meaning that all our interfaces are now up. Now we are going to continue with the configuration by configuring communication. We want to ensure that all these interfaces are able to communicate. Like while we are on this PC, you should be able to communicate with the loopback 0 on the internet router. So we are going to configure static and also the OSPF routes. So let's give these various PCs IP addresses. So this first one was 192.168.1.10. With its gateway being the gateway will be the IP of the virtual with the virtual IP 168.1.1.3. Come to this other PC also. This one will be 192.168.1.11. Gateway will be 192.168.1.3. Here on our last PC. 192.168.1.12. Gateway of 192.168.1.3. After that is done, now we go to we said we are going to configure a default route on this router number 1 and router number 2. So enter into our router number 1. You can see now we need to log in first. Enable config CCNA. We configure the static route, so enter the configuration global configuration view. So IP route here. Configure default route will be 0.0.0.0 with a mask of 0.0.0.0. Now our next stop will be this interface on this ISP number 1, that is .2. So our next stop will be 100.100.100.2. Come to your then IP route any destination 0.0.0.0 mask with our gateway will be 200.200.200.2. That will be the gateway. So we are told that our ISP1 internet and also ISP number 2 will work, will be able to communicate through OSPF. So enter that. So Cisco enable CCNA. So config terminal So router OSPF process number 1. Here we are going to advertise the network of 100.100.100.0 with the welcome mask of 0.0.0.3. Area here will be area 0. Then the network of 110.110.110.0, welcome mask of 0.0.0.3. Area here will be area 0. After that, we go now to the ISP. On the ISP, we are going to configure 3 networks, the network for the loopback and also the network for the physical interfaces. So Cisco enable CCNA config terminal router OSPF process here. Let's give it process number 2. We said even if the process number is different, the OSPF should be able to work well still. So network here will be 110.110.110.0. Welcome mask of 0.0.0.3. Area here we are on area 0. I should be able to see her neighbor established between internet router and OSP router number 1. So we can see here the neighbor is 110.110.2, and the state has changed to a full state. So next we are going to advertise the network for the loopback. So 8.8.8.8 welcome mask of 0.0.0.0 because it is a /32, and our area here will be area number 0. Then we are going to now configure the network of 210, network of 210.210.210.0 mask of 0.0.0.3. Area here we are on area number 0. Then lastly, we configure OSPF on ISP router number 2. Cisco enable config terminal CCNA, and config T. After that, a router here will be OSPF process number 3, network of 210.210.210.0. The mask of 0.0.3. Area here will be area 0. Should be able to see the neighbor established with the internet. You can see here the process ID is number 3 and the neighbor has been established with the loopback interface. We said that the router ID will be picked with, in case there is a loopback configured on that interface, it will pick the highest loopback, but if loopback is not configured, it will pick the highest interface IP address. Then we attach the network that connect to the downward router 200.200.200.0 mask of 0.0.0.3. Area here will be area 0. With that done, let's now check the connectivity. Can we ping 8.8 while we are on this router number 1? So ping 8.8.8.8. The success rate was 100%, meaning that 5 packets were transmitted and also 5 packets have been received. The same should also happen while you are on this other router, meaning that OSPF and also the default route are working on appropriately. So ping 8.8.8 You see, the same thing happened. So our success rate was 100%. 5 packets transmitted and 5 packets have been received. After having done that, now let's do some commands, verification commands. So show running config. When you show running config, we are able to see what we've configured so far. The interfaces, how we've configured the interfaces, and also the description. You can see there. OSPF here, and show IP interface brief. Then we are going to exclude unassigned. So we are going to see now here gig1, the IP addresses, that the IP address that has been given to gig1 and also IP address that has been given to gig/1. And the protocol is up all, meaning that all the interfaces are operating well. They are in the up state. Having done that, what we are going now to do now is now to configure now the VRRP. Now we said with our fault tolerance solution, it will provide a continued device operation, so that in case one of the device goes down, the other device should be able to take over and ensure reliability and availability in our network. So let's now go now to configure the VRP. Now we're going to route that router. So config terminal. In the configuration terminal, we're going to enter the interface. We're going to enter interface, this interface, gig0. Before we continue configuring hot standby routing protocol, let's configure the part that we were told. So on that, let's configure that access list. Now we are going to tell it number 10, and then permit. We're going to tell it to permit source of 192.168.1.0 with the wildcard mask of 0.0.0.255. IP NAT inside, and source here will be source list here will be number 10. Then interface will be interface gig0//1. That will go to connect to the upper one. Then we tell it overload. After that is done, you also do it on this other side. Configure the NAT. So config terminal. Here access list here will be number 10, permit 192.168.1.0 with the wildcard mask of 0.0.255. Then IP NAT here will be inside. Then we tell it a source number list number 10. Here interface gig0/1 overload. Then enter interface gig0/0. You tell it IP NAT inside. Then gig1, tell it IP NAT outside. Come back to router 1 and complete it. So interface gig0/0 IP NAT inside. Gig1 is IP NAT outside. After that is done, now let's exit, and now configure the HSRP. So interface gig 0/0. We are now going to configure HSRP. First of all, we are going to create the standby group. So standby group. So with HSRP, one device will act as the active while the other device will be on standby. The difference between HSRP and VRRP, the first one was that HSRP is a Cisco proprietary protocol, while VRRP is an vendor specific protocol. Also, with the VRRP, we have got the master and also the backup. So one router will act as the master and the other routers will act as the backup. With HSRP, one device act as the active and one device act as the standby. Then other devices will be in the network. But for VRRP, one device act as the master, then one or all the other remaining routers will act as the backup routers. So that's the difference between HSRP and also VRRP. So standby group number one, let's give it group number 10 and group number 10 here. Before that, let's give it, so we have got two versions, that is version 1 and version 2. Let's give it version number 2. After that, standby process here, we'll give it 10. Then IP, the virtual IP was 192.168.1.3. You can see here gigabit 0 GRP group number 10. The state has started to be, we are in init state. Then standby here with group number 10. I will tell it to preemption. So preemption means that in case a device with the highest priority enters our network, it will be act as the active device. Like, let's say if I come into the network and I have a higher priority, I will be the active one. So that is what is called preemption. You take over the role. Then I will tell it the priority. Let's give this device a higher priority. So standby number 10, priority here will be 105. After that, we are going to go to our second router, exit, interface gig 0/0. We tell it standby version here. We are working on version number 2. And standby group number here will be group number 10. IP 192.168.1.3. That is in it. So then standby group number 10, we tell it to preempt. Because the default priority for the HSRP in Huawei devices is 100, but the other one is set to 105, meaning that because it has a higher priority, it will take the preference, it will take the role of active. So like the one with the higher priority will win the election. So we have in case a new device with the higher priority enters a network, we'll have a new election because it will take over the role of being active, and the other one will be standby. So let's see something here. So show standby. When you show standby here, you can see gig 0/0 has been configured with group number 10 with version 2, and the state is active. So the state is active and preemption has been enabled. Now when we go to router number, this one should be the state should be standby. So show standby. When you show standby here, we are told that gigabit 0, it is also telling us that it is active. which here should be give us the state of being a standby. So let's try and troubleshoot and see where we have got a problem in this part. So let's come to this side. This interface actually is where we were supposed to configure the hot standby routing protocol. So not gig 0. So when you look at this, all is gig 0 is the one that connect to the ISP2, but this one is gig 1, not gig 0. So we're going to change that and see if now it will be able to take effect. So config terminal. Enter first of all. You are going to undo that we configure on gig 0. So gig 0/0. Tell it no standby 10. Should be able to delete that. Then we enter gig 1. On gig 1 we tell it standby version here will be version number 2. Then standby group 10 to tell it IP here will be 192.168.1.3. Then tell it standby preemption number 10 to preempt. Now let's show standby. When you show standby here, you can see now this time now the state has changed to a standby. So meaning that router number 2 will act as the standby while router number 1 here will be our active. So show brief, show standby brief. When you show standby brief, you are being told here group number 10 and priority is 105. Then it is active and the state is active and the active is local. Then the standby address will be 192.168.1.2. That is for the for router number 2, while the virtual IP is 192.168.1.3. So let's come to this this router and show standby brief. When you show standby brief here, a group is 10. Priority is 100. That is the default for the Huawei. And the state here, it is a standby. And active is 192.168.1.1. That is router number 1. And standby is local itself. Then the virtual IP is 192.168.3. So when you ping the gateway, I should be able to go. So you see the packets for the gateway is going successfully. Now we are sending packets and also we are receiving packets successfully, meaning that now the virtual interface has taken effect and also the VRRP is working very well. So like let's show here that we are going to trace route to that. You can see here the gateway is 100.100.100.2. So let's simulate this interface so that it has been shut down. So config t interface gig 0/0, shut that interface, and let's give it time for it to reconverge. Now come to and show interface brief. Standby is unknown. You can see here we've shut this interface. Now we are on this one, on this router number 2. We can see now it has changed to the status has changed from standby to now active, while the standby is still unknown because now we've shut that interface. It doesn't know the standby. So meaning that router number 2 now will act as the active router, where when packets are sent to that router, it will deliver it to the upstream device. You've seen that how that takes effect. Now we are going to turn back our upstate our interface. So no shut to bring it back and see now if now it will be able to reinstate its initial role of being active, and now if router number 2 now will be will go back to the standby state. Now see, it has gone back to standby state. Now we are on router number 2 because router number 1 has come back to the into our network. Now router number 2 will go back to the standby state. As you can see here, it is now in standby state. But while that other router went down, it became active, and now this router is now the one that is active, and the standby stack has been is now again the router number 2. So that's how you do it, guys, and thank you very much for watching these videos, and let's meet in our next video.